Okay. When we first started this unit, we kind of touched on the rock cycle, and I said that we would come back and revisit this at the end after we kind of learned a little bit more about the rocks, specifically the different types of rocks. So this is kind of that revisitation. All right. Something before we get going with this, something to remember. So even though this diagram is set up the way it is, not all rock cycle diagrams are set up the same way. Things might be in different positions. They might go a different direction. All that stuff doesn't matter. It's, if you understand the concepts, if you understand the content, the processes, the ideas of what's happening, then it doesn't matter because you're understanding what's happening. All right, so with this one, so if we start with magma, as that magma cools, crystallizes, becomes a rock, then that gives you igneous rocks. So this picture, this is an example of granite, which has a coarse texture, so it's very large crystals. It's intrusive, so it forms underground. If this rock is uplifted, so if it's pushed upwards over time, or if the material that was above this rock when it formed, because it is intrusive, is weathered and removed over time, but this is exposed to the elements in the atmosphere, then weathering takes place. So remember, weathering is basically anything that's weathered: rain, snow, winds, ice, hot, cold, any of that stuff. That's going to weather this rock, break it down into smaller pieces. It gives rise to sediment. So sediment, that's the collective term for those smaller pieces. So here we have some sand, which that's what sand is sediment. And it used to be part of much larger rocks and mountains, and now it's not.
I always thought that shell is a broken up shell.
That's what sand was made of?
Yeah.
I mean, it can be. I mean, there can be parts of shells that break down and are mixed in with that. Yeah. But, the vast majority of sand is quartz, mostly quartz that's, left over from granite that's broken down in the ancient mountains and things like that. But yeah, it can definitely be part of it. So with sediment, erosion is the first thing that takes place. So after weathering and after sediments is kind of formed, erosion is a process where it's moved somewhere else. The main agent that does this, the main thing that causes erosion is water. It moves a lot of material. It can move a lot of material. So the sediment is moved somewhere else. Remember sediment sorting. So this is that thing where you can kind of think of it two different ways. You can think of it as the largest pieces of sediment moving the shortest distance, or the smallest pieces of sediment moving the greatest distance. It's the same thing, it's just kind of how you want to look at it. So as the sediment is moved, it's sorted. And then there's compaction and cementation. So as the layers of sediment start to stack up, the weight of that material is pressing down and compacting all of that sediment together, removing extra space between those pieces of sediment. And then cementation, this is a process of where it effectively is kind of glued or cemented together with dissolved minerals that are in water. After that water evaporates over time and this is cemented together with those minerals, that's lithification. So this is the process of where it's it's not millions and millions of pieces of sediment. It's now one solid piece of sedimentary rock. So it's gone from individual pieces to one piece, where it's cohesive. So it gives us sedimentary rock. So then that rock can be buried over time. So, you know, more sediment, more rock on top of that. If it's buried deeply enough, then you can be exposed to, you know, pressure and heat that's great enough to change into a metamorphic rock. So remember, change is the key term, is the key concept of metamorphic rocks. It starts as one type of rock, something happens to it, you know, most often pressure and heat, and it's changed into a metamorphic rock. It's kind of the main thing to remember. And this is a picture of quartzite, which is a non-foliated rock that's formed from the parent rock sandstone. So the grains of sand are kind of melted and fused together into larger crystals. And in metamorphic rocks, if they're heated to the point where they melt, then they become magma, and then we're back where we started. It's kind of the outer portion of the rock cycle. Something else to remember about this: this is not a fast process at all. I mean, this is this is something that could take billions of years to happen. Something that it's not like every piece of rock has to go through these steps, but it's definitely not a quick process. Now, with this just being the outside part, there are some kind of shortcuts. So, for example, if you're going from igneous rocks to metamorphic, if that igneous rock is exposed to heat or pressure, it can become metamorphic and kind of cut off that bottom loop. That's one kind of shortcut. Metamorphic rock can become sediment if it's weathered. Any type of rock can. And along those lines, sedimentary rocks can go right back to being sediment through the process of weathering. So just as it's formed, and then once it's exposed to the atmosphere and the elements, weathering can take place, and you can break it right back down into sediment. So these are kind of the shortcuts there. And then this last one, notice this one goes the other way, and I'll let you just kind of do this one on your own. I would recommend actually reading the things. If you do, it pretty much tells you exactly which one goes in which one. But I was pretty surprised. I've put this on quizzes before, and there have been a lot of people that have missed it. They haven't even tried it. Like I said, if you read it, you'll see that the answers are right there. So yeah, like I said, I'll let you work on that one. Does anybody have any questions or any slides I need to go back to? Have I missing you?
Can you go back to the last one?